So in this section, we're going to look at a problem where we find the standard deviation and the coefficient of variation. So in problem 37 on page 125, stock prices, the following are the closing prices of Google stock for each trading day in May and June. So in this case, we can look at these as actual populations. So in this case, for May, this is all the trading days in May. So we can look at that as a population of all the data for the closing prices of Google in May. In June, we can look at this as all of the trading day prices in June of 2013. So if we've defined our universe very narrowly, we can now make them populations. And the question in this particular problem asks, find the population standard deviation for the May prices. So again, what we're going to do is we're going to enter this data set into L1 under the stats key. So we enter that into the stats key. We go over to one variable stats and we hit L1, and here are the results of the May prices. You can see that for May, the mean is equal to 872.51 approximately. And the population standard deviation in this case is sigma x. Most of the time in this class we're not going to use that. But when they say population standard deviation, we have the choice either between this value or this value. And for standard deviation, most of the time we'll use Sx, but in this case we're going to use sigma x. And in this case, it's 18.528. For June, we do the same thing. We put this into L2, and we did the stats for L2, and we get the mean value is approximately equal to 881.8. So the price of the stock, the average price of the stock, looks like it's gone up for Google. But when we start talking about the population standard deviation, we get 18.482. Now the question is which is more volatile? To answer the question of whether a stock is volatile or not, there's two ways you can look at asset pricing for volatility. One is you can compare the standard deviation between two populations. In this case, we saw that for May, we had a population standard deviation of 18.582, whereas for June is 18.481, I believe. In any of the case, you can see that May's asset prices are a little bit more volatile based on the standard deviation of the populations. But now when we look at the coefficient of variation between the two populations, remember what CV is. CV is equal to sigma x divided by x bar, or in this case, it's mu, right? Because we have the population mean in this particular case. And so for May, it was 18.582 divided by, let's see, what was it? 872 point something, right? In any event, when we do the calculations, right, we end up with a CV of 0.21 for practically both cases. And that's telling us that really the volatility really hasn't changed very much between May and June. And that's a good thing in terms of asset pricing. A lot of volatility means there's a lot more risk involved in your investment strategies. Well, that concludes this particular problem in chapter 3.2.